Lecture 28D, Taylor expansion, small separation. You see? Now, at the end, we'll get the Riemann curvature, okay? So, let's repeat from the lecture 28, this case, the previous one, 28C. I just copy from there and I repeat over here, okay? Then I call this expression 1. Now I will apply the Taylor series. You see, this is A plus delta x1, this at A. This is B and the B plus the delta x2. I will apply the Taylor series on these two terms and on these two terms. Okay, the algebraic manipulation is quite simple. Okay, you just derive here the Taylor expansion. You see, A plus delta x1, okay, is at A plus partial derivative with respect to x1, delta x1. You see, the right hand side is at A. This is equation 2. Now, likewise, B plus delta x2, again, this is I repeat here at B plus partial derivative with respect to x2 at B delta x2, relation 3. Now we'll substitute 2 and 3 into 1, right over here. You see, again, I will insist in saying that the algebraic manipulation, okay, is quite simple, okay? So I substitute and cancel the symmetric terms, okay? When I substitute over here, I will cancel the symmetric terms. This leads to this relation over here. You see, it's again, it's quite simple, okay, the algebraic manipulation. So you see, on the right hand side at A and at B, okay, after the Taylor expansion. So I can group, okay, this one here, I integrate dx1, okay, is delta x1, okay, if I integrate, because the variable is, in this case, is delta x1, okay, so I integrate this from 0 to delta x1, this will be 0, you see, this will be delta x1. I think it's better if I change like this from 0 to delta x1. You see, likewise, this from 0 to delta x2. You see, I integrate this. So this leads to delta v mu. You see, mu here is free index, okay? Delta x1, delta x2, that multiply, okay, the remaining terms after cancellation. These are the remaining terms which involve the partial derivative here. So I can expand, you see, this product, okay? This is partial derivative of a product, this is partial derivative of a product. I just expand this and write right over here, you see? So this is delta x1, delta x2, that multiply this expansion. Now, in general, instead of work on x1 and x2, the coordinates, we in general will work with the general coordinates alpha and beta. So I substitute 1 by alpha and 2 by beta, and I substitute here and I repeat over here. You see, that's quite simple. So this leads, you see the parenthesis here, by definition, is called Riemann curvature. This R, mu, this is nu, alpha, and beta. All these are free indices, you see. The only dummy index is gamma over here, you see. It's quite simple. Just so I repeat over here this Riemann curvature, okay. This is mu, nu, alpha, beta. You see, this is the right hand side. You see, I just substitute 1 by alpha and 2 by beta, and this I'll write down. So this, there are here, you see, 4 free indices, okay? And 1 gamma is the only one dummy index, okay? So I can apply this to cylindrical coordinates, spherical coordinates, you see, and it'll be easy to see if you have a flat space, this curvature here will be 0 because the Christoffel symbols for flat space is 0. So there is a curvature which is 0, okay, when you deal with the flat space, okay, that's it.